1983, Professor William A. Fowler and Professor Subramanian Chandrasekhar received the Nobel Prize in Physics, the most prestigious award of all time in science. That year, the theme of the Nobel Prize in Physics was stellar evolution. It came as a surprise to the scientific community that Sir Fred Hoyle, a pioneer in this field, was excluded from the list of Nobel Prize, for this was an area in which Fred Hoyle had richly contributed.
Fred Hoyle was an iconoclast. He did not necessarily believe something which was believed by everybody.
He was a man absolutely dedicated to trying to understand the universe.
I think he's an absolutely remarkable man. It's probably fair to say that he changed the way we see the world.
His contribution to nucleosynthesis formed one of the very important bases of overall structure of modern astronomy, as it were.
Being my father's daughter was a bit like being the daughter of a pop star. You have no idea the excitement my father could generate.
Sir Fred Hoyle was one of the most creative and outspoken astrophysicists of all time. He is remembered for his contribution to the theory of stellar nucleosynthesis and his often controversial stance on cosmology, such as steady-state theory, panspermia, molecular clouds, etc. Despite his numerous contributions to cosmology, Sir Fred Hoyle was one of the unfortunate scientists who did not receive the highest award in science, the Nobel Prize.
Let's call it the bandwagon bus in which everybody who believes in the popular theory rides. Now, you can be of three kinds. You can be late in boarding the bus, so you miss the bus. The second is you get on the bus at the right time, so that for your career you are making the right kind of contributions and you succeed. If you are too much in advance of the bus will come and knock you out. Now, in the case of Fred Hoyle, this was the last alternative. He made many statements and contributions, but they were before their time, and after the bandwagon came there, they had forgotten that he had said this.
Fred proposed that the energy-producing reactions in stars, known as nucleosynthesis, was the origin of all chemical elements.
I worked on nucleosynthesis. I would say, as a result of my work, he and I realized one had to look for other ways of producing the particular kinds of nuclei that he was interested in.
The way in which energy is released during the process of nucleosynthesis in the interior of stars is pivotal to our understanding of the manner in which stars evolve, stellar evolution as it's called. And this is arguably one of the pillars of modern astronomy.
He was contributing to formation of elements, that is chemical elements, how were they formed. So there was a famous paper by Burbidge, Fowler and Hoyle, which tells you how these elements were synthesized in stars. And this is called B²FH as the short form for the four authors.
The B²FH paper is considered a landmark in the origin of the chemical elements. The four authors were Margaret Burbidge, Geoffrey Burbidge, William A. Fowler and Fred Hoyle. As Fowler said in his autobiographical sketch, the concept of nucleosynthesis in stars was first established by Hoyle in 1946.
He was almost the first, possibly the first, to recognize what is nowadays taken for granted, that almost all the material that this planet is made of was formed inside stars. Before the sun formed, before the planet formed, there was still 10 billion years of stellar evolution, and these stars turned hydrogen and helium into carbon and oxygen and neon and iron and zirconium and barium and lead.
Sir Fred Hoyle was often involved in controversy due to his honest opinions. He established the Institute of Theoretical Astronomy in 1967, which was later renamed as Institute of Astronomy, Cambridge. Though his leadership led this institution to become one of the premier institutions in the world, he left his position as a professor in 1972 and the directorship in 1973.
I was a PhD student in Cambridge and a postdoctoral fellow there. He had left Cambridge after a disagreement with Cambridge in the 70s, but towards the end of the 80s, Fred Hoyle started coming back to Cambridge for periods of a time. His collaborators, Professor Narlikar and Professor Wickramasinghe, the Burbages, they all started coming to Cambridge when Fred Hoyle was there.
One of his reasons for his arguments with the scientific establishment in Britain was because he felt that the system of checks and balances, grant systems, referee systems effectively favoured the big beasts like himself and it made it very easy for young enthusiastic minds to be shut out.
He set up the Institute of Astronomy, and after he had left, the Hoyle building was named after him. There's a life-size statue of Fred Hoyle in the gardens outside that building. They celebrated Professor Fred Hoyle's 75th birthday. I remember that this 75th birthday celebration was held, pictures being taken with Professor Fred Hoyle standing next to his statue and everybody around. I wish we had camera phones then. I don't have records of these pictures. Almost everybody would have now taken selfies with those illustrious people around.
American astronomer Edwin Hubble proposed the Big Bang theory in 1929, a theory of the origin of the universe most widely accepted today. However, to Fred Hoyle, the Big Bang theory seemed to be far from perfect. There had to be an alternative cosmology.
Why do we need an alternative cosmology? So the Big Bang requires you to make an assumption that there is lot of non-baryonic dark matter present in the universe, and that in itself I feel is an artificial assumption put in to prop up the theory, otherwise the theory breaks down. Steady-state theory was one of the brilliant ideas proposed by three scientists, that was Hermann Bondi, Tommy Gold and Fred Hoyle. And they had proposed that the universe is without beginning, without an end, and it continues to expand at a steady rate. But if something expands, its density falls. So to keep it in steady state, you need to produce more matter in place of the old one. So you have to continuously provide matter.
The steady-state theory immediately aroused bitter opposition.
So this idea was rather new to physicists, who thought that the conservation of matter and energy is being violated. But what Fred Hoyle showed with his mathematical work, that if you had negative energy fields, then creation of matter does not violate principle of energy.
Numerous attempts were made to reject the theory with observational arguments. Martin Ryle was one of the most powerful and controversial critic of this theory.
Well, Martin Ryle was a radio astronomer who conducted counts of radio galaxies out to different distances, and he found that the number of radio galaxies per unit volume went on increasing very rapidly as you went further and further, and he came to the conclusion that this kind of behavior is not explained by the steady state theory. So he said that his data was disproving the steady state cosmology.
I think initially his feelings of argument, if I can book it with Professor Ryle, was because Professor Ryle was a deeply religious man, and you know, let's be honest, between us all standing in this camera, you know, God created the world in 7 days or whatever it says, you know, Big Bang, and I think that was his initial stepping backwards. I think when the evidence continued to come, he obviously agreed with it.
By the 1960s, the steady-state theory had been completely rejected after the detection of cosmic microwave background radiation. But Fred still felt that a different approach to cosmology was indeed needed. Together with Jayant Narlikar and Geoffrey Burbidge, in the final years of his life, Fred worked out a quasi steady-state theory of the universe. The result of the collaboration between Hoyle, Narlikar and Burbidge appeared in the form of a book titled A Different Approach to Cosmology.
Well, the quasi steady-state theory would like to have certain observations done so that it can be tested. Now, one of them is that it predicts that there can be or should be very old stars present, something like 20 giga-year old stars. If that is found, then it will be difficult to explain in Big Bang, but the quasi steady-state can do it.
People believe he clung to the steady state theory with sort of like some sort of old Harrigan. This was not my father. I actually asked him this question. It's very rare for me to do so. And we were having English high tea, which is scones and jam and tea and things by the sea. We were just the two of us near where they went to live. And I said, "What do you think about Big Bang?" And he took a large bite of scone and jam and cream, and he said, "Well, I don't like it because it leaves more questions than it answers." But he said, "The evidence points towards it," and then took another bite of his scone and finally he had a very good, nice grin, and then gave me a big grin. He said, "I'm difficult, but I'm not irrational."
In 1960, Fred was joined by Chandra Wickramasinghe, a research student from Sri Lanka. They together proposed that life on Earth had an extraterrestrial origin, an idea popularly known as Panspermia.
I think it's true to say, isn't it, that if your theory is correct, life not only may be spread throughout the universe, it must be.
Surely there must be many places where this has happened. Do you have an idea of the numbers?
The numbers must be very favourable, Fred. There are billions of stars in the galaxy which are probably very similar to the Sun and very similar to the extent of being able to support planetary systems. So it would really be very surprising if life is not, if the galaxy is not just teeming with life.
However, the scientific establishment was not ready for such a provocative idea at that time.
I'd learned from Fred Hoyle that you don't really take note of other people's criticisms. You have to really take note only of your own self-criticism. He instilled in me a kind of obstinacy, meaning that you should not be deflected from your intended path unless you really have very powerful reasons to shift away from it.
I've seen Professor Hoyle give the very famous lecture at the University of Oxford on his theory of how life came from outer space through comets. And again, this lecture, the Halley lecture, in the 80s, I remember there were 300 to 400 people in the room. Nobody believed a word of what he said. But you came out completely convinced that there was a case for it.
Fred Hoyle later collaborated with his student Jayant Narlikar to perform few high-altitude experiments to detect organic materials with possible origins in outer space. During these experiments, a few new species of bacteria were found high above the ground in the stratosphere. One of these species was named Janibacter hoyle in the name of Sir Fred Hoyle.
These experiments are called as astrobiology balloon experiments, and those were conducted twice, once in 2001 and next time in 2005. Primarily, these experiments were started to test the Hoyle-Wickramasinghe hypothesis of panspermia. So 2001, IUCA, TIFR and CCMB in Hyderabad, they did these experiments. Those experiments were successful. They could indeed find some live bacteria over there, and in fact some new species of bacteria. Since this experiment was done to prove the Hoyle-Wickramasinghe theory of panspermia, this organism, which was found in the air sample that was collected at 41 kilometers, we named it as Janibacter hoyle. It's very creditable that a person who do not have any formal background in biology or microbiology come up with this theory of panspermia. That's a very genius of him to think of such an explanation.
Fred Hoyle was a great science communicator. He knew that science is not only for the scientific community. Laymen can equally be interested in the wonder of science if it is delivered in a simpler way.
His real interest was in projecting science to people who were non-scientists. People have come up to me and said, I never thought of science as being interested until I heard your father talk on the radio.
I would say there are very few scientists who take science popularization as a serious part of their work, but Fred Hoyle was one of them, and he was very good both in his speeches on scientific subjects, but also in his writings, as well as television interviews and so on.
Fred Hoyle was awarded the 1967 UNESCO Kalinga Prize for the popularization of science through his television programs and lectures addressed to the general public. He had written many fiction and non-fiction books, among which The Black Cloud is the most popular one,
in which he had made the conjecture that inside the galaxy there are regions which produce somehow chemical elements, not chemical compounds. So he said that we should look for such regions inside the galaxy, and they could be called molecular clouds because molecules were found. That idea was part of the whole story, and the science fiction story was very popular, and the idea got known.
Well, he was a wonderful communicator of science. I knew about him from a radio broadcast or series of broadcasts he had given some years earlier when I was still a schoolboy, but they were absolutely fascinating. You know, Fred's one interest in life was to try and understand things, and if you wanted to try and understand things, you were his guy.
Sir Fred Hoyle was born to Mabel and Ben Hoyle on the 24th of June 1915 in the village of Gilstead near Bingley, Yorkshire. He married Barbara Clark on the 28th of December 1939. They had a son Geoffrey and a daughter Elizabeth. He had a strong personality since his childhood. He skipped school very often. For him, the outside of school was more interesting than the inside. At the age of 8, one day, he had an argument with his teacher about a flower petal. The teacher said that the particular flower contains precisely 5 petals. However, Fred found a flower of that kind with 6 petals. He told the teacher that the flower need not necessarily follow the rule of 5 petals. The teacher slapped him for having a different opinion. So he decided not to visit the school after that. Fred was homeschooled by his mother for the rest of that period. This incident shows the curious and courageous mind of Fred since his childhood. He was born to fight for what he believed in.
I think he was always a man in a hurry in some senses. He saw so many questions that needed answering in his mind, and with the limited availability that you had before the internet, he looked for data, and when he found an answer that might fit, he would then talk to people and see whether it fitted. That meant that he got things often horrendously wrong, but when he did get them right, he got them extraordinarily right, in a way that is almost unbelievable. How can you believe it at not much older than you? He walks into Willie Fowler's office in Caltech and said, this part of a carbon atom exists because I exist.